temperature on VI characteristics. What is that? Effect of temperature on VI characteristics. Effect of temperature on VI characteristics. So till now we have studied what are these VI characteristics. So it is based on both the qualitative analysis as well as the quantitative analysis, right? So now how is the temperature is going to affect the VI characteristics? So to understand how the VI characteristics are going to get affected based on temperature, first we should understand what is the relation between the temperature and the current. So anyway, from the equation we can see that I is equal to I naught into e power V by eta Vt minus 1. So directly it is not related to temperature, but what is making it to have a relation? Vt and I. Because we know that Vt is given by T by 11,600. So somewhere or the other, current is related to temperature. Clear? So as how this temperature is changing, you are going to see that current is also changing. So how do we understand? And not only that, based on the applied barrier voltage, you see that the barrier potential is changing. So based on that barrier potential, you also see that current passing through the diode also changes. So finally, to conclude, the VI characteristics, okay, depends upon temperature. May not be directly, but with respect to two cases. One is with respect to the barrier potential, and the other one is with respect to the temperature. Okay, and the other one is with respect to Vt. Because Vt in it we have the temperature T. Now, how is this to understand much more clearly? So we say that whenever there is a change in temperature, let us say temperature is increasing. So whenever there is an increase in temperature, what is it we are saying? More number of electron hole pairs are generated, isn't it? That's what we said. Initially, all the electrons will be in covalent bond with one another. But once, whether there is a change in voltage or increase in temperature, any one of these two might result in breakage of bonds. So once bonds break, okay, once bonds break due to change in temperature, what happens? Electron hole pairs will be created, and when electron hole pairs are available freely, they try to diffuse through the junction, and when they try to diffuse through the junction, what happens? We see that current flows, isn't it? So now, when temperature is increased further, what happens? This number of electron hole pairs that are generated also increases. So once this electron hole pairs generated increases, diffusion of more number of charge carriers is taking place. As a result, you see current flowing through the diode also increases. So as a result, what happens? When you apply the voltage at higher temperatures, you see that current increases at the lower values of voltage itself. For example, if I take temperature 10 degrees centigrade, let us say applied voltage is V1. So for this V1, I see current I1. But if I increase the temperature to 20 degrees centigrade, what happens? This takes place. So what is happening for the same V1? What is that I see? I see that some amount of current I2 flows. But what is that current I2 when compared to I1? Anyone? What is this magnitude of I2 when compared to I1?
Increases.
Increases. Very good. It increases. That means for higher temperatures, for the same voltage, I see a large amount of current. So if I try to plot it in the graph, how can I see? Let us say this is at voltage V1. I observe this as current I1. At what value? At 10 degrees centigrade. Now, for the same V1 at 20 degrees centigrade, what happened? I observed a large amount of current which is greater than I1, which means I found this value in before V1 itself. So somewhere here. So that means if I try to plot the characteristic curves for different values of voltages, you see that the characteristic curves are moving closer towards y-axis. Because the same I1 is available at a lesser value than V1 for temperature T2. Okay, so as temperature is increasing, you see that current increases, so the characteristic curves move closer towards y-axis. So this is what we treat as, or we call it as, effect of temperature on VI characteristics. Effect of temperature on VI characteristics. The same we say, instead of giving this entire explanation, we come out with a single statement. That is, for every 1 degree raise in temperature. Okay, we say that for every 1 degree rise in temperature. For every 1 degree rise in temperature. Okay, we observe that the one that is getting immediately affected is not I, instead I naught. Okay, for every 1 degree rise in temperature, I naught increases. Increases by how much? Increases by 7%. Now your question is, earlier you said I is increasing, but here you are mentioning I naught is increasing. So increase in I naught finally leads to increment in I. How? Based on our diode current equation. I is equal to I naught into e power V by eta Vt minus 1. So based on this, what is happening? When I naught is increasing, automatically I is increasing. Okay, so this is a very, very important relation. So for every 1 degree rise in temperature, you see that the reverse saturation current increases by 7%. This is a very, very important question which is expected even in GATE examination. So those who are aspiring for GATE, you need to remember. The same we also say like this. Instead of saying or calculating it for every 1 degree centigrade, you can calculate it for 10 degrees centigrade, so that if any question is asked, at the temperature T1 current is so and so, what is at temperature T2 the current is. So if T1, T2 varies by very large value, you can't go on calculating for every 1 degree each and every time. So what we do is, we also say the same statement as, for every 10 degrees rise in temperature, okay, for every 10 degree rise in temperature, we say that reverse saturation current almost doubles. What is that? We say reverse saturation current almost doubles. So this is how we have the relation between the characteristics and the temperature. Characteristics and the temperature. So the same thing is given out like this. So I naught, okay, measured, if you want to measure this I naught at temperature T2, I naught to be measured at temperature T2. It is always given by IO1, that is reverse saturation current at temperature T1 raised to the power of 2 with a difference of T2 minus T1 by 10. Raised to the power of T2 minus T1 by 10. So how to understand this relation? So here this is for every 1 degree raise. This is for every 10 degree raise. Let us say, for suppose you are given a temperature change which is greater than 10 degree. So how can we evaluate the reverse saturation current? So for that, this is the expression. So usually this is on what you will be expecting questions in the examination. Okay, so I naught of T2, that means reverse saturation current to be evaluated at temperature T2 can be obtained as I naught 1. I naught 1 stands for reverse saturation current at temperature T1 into 2 power T2 minus T1 by 10. So T2, T1 are known to us. So temperature T1, temperature where T2 is greater than T1. So you will take the difference of these two and substitute in it, and you will find out the reverse saturation current at T2. Okay, so this is one thing. And the other one you can have is how voltage is getting affected. Okay, so for that you have dV by dt is equal to minus 2.5 millivolts. What is it? dV by dt is equal to minus 2.5 millivolts. How to understand this? For every 1 degree rise in temperature. What is it? For every 1 degree rise in temperature, you observe that voltage that is received by the junction, okay, always decreases by 2.5 millivolts. What is it? That's why this minus is shown. Minus indicates decrement. So increase in temperature results in voltage across the junction to decrease. By what value? By 2.5 millivolts. So when voltage received by the junction is decreasing, automatically current gets affected. So current decreases. So when current decreases, what happens to the reverse saturation current? It moves further closer towards x-axis. Okay, it moves further closer towards x-axis. So whether it is with respect to I naught or with respect to V, you observe that the characteristics they move closer towards y-axis here. Here they move closer to x-axis. So this is how we have the effect of temperature on VI characteristics. So this is a very, very important equation which you can expect in GATE examinations. Okay. So this is all about the quantitative analysis. And tomorrow, please sit along with your calculators. Please note down all these things which I am discussing on the board in your notes. And tomorrow we will work out few problems based on this and the diode current equation. Then we will move on to the next concept which is called as diode capacitances. So is this mode of teaching understood for you? Are you able to see the board clearly? I want your feedback.
Yes, ma'am.
Are you comfortable with this way of teaching?
Yes, ma'am.
Or you want me to go with PPT? Quickly respond. We are moving out of time.